Hello, students, and welcome to our algebra lesson today. First, we're going to do our Do Now, where we talk about pursuing our personal interests. Our objective, for today will be to identify the zeros of a function, and we're going to use the skills that we've been learning to describe a graph. Our essential question: what are the zeros of a function? How do I identify the zeros of a function algebraically and from a graph? And what are the components that I should note when describing a graph? Our assignment would be to watch the video on identifying the zeros of a graph and describing a graph. We have 3 pages today, but it's not very onerous. A lot of them are graphs, so they take up a lot of room. So let's just remind you that we have 3 pages today. For our exit ticket, I just want you to complete this sentence. The zeros of a function are also called the blank, blank, or blank. And for homework, we have homework 5, zeros of a function, and that is 1 page. We'll talk about that a little bit because I'm going to want you to use Desmos to do part of it. Important notes: if you've been sent an assignment spreadsheet, make sure you complete your unfinished work. Come for extra help if you need it. You should do your homework when it's assigned, or at least some of it, so that you don't forget the skill. And next Thursday, possibly Friday, I'm going to say, but we're going to have our unit test in December. Okay. So I have my daughter sent me pictures of my grandchildren, so I just thought I'd share them with you. Cardboard box for the win. Sometimes that's really just what you need, is a cardboard box to have some fun. So I was missing my grandchildren and thought I would share them with you. So let's get started. Our Do Now says to think of an interest you wish to pursue. What are the positive and negative factors that will help or hurt you as pursue your interest? For my example, I would love to learn music, learn how to read music, maybe play an instrument. And, positive factors, I'm good at learning things. And I have friends who are musicians, so I have musical friends. I would say the negative factor would be that I have no time. So that would be something maybe not until next summer, if I want to try that then. But I want you to think of an interest that you wish to pursue, and whether it's getting better at math or learning how to dance or something else, maybe a sport or a game. So this is our exit ticket. We'll come back to it later. And so let's talk today about zeros of a function. Boy, my handwriting, let's clean it up a little bit. Let's find a brighter color. So, zeros of a function. Okay, so what are the zeros of a function? The zeros of a function are, and we can think of this graphically and we can think of it algebraically. So let's start with the graph. So graphically, it's the points at which the graph crosses or intersects the x-axis. Now, algebraically, what does this mean? So algebraically, what this means is the point at which the function equals 0, or the point. Now, I'm going to say point or points. Okay, sometimes it can cross the graph 2 or 3 or more times across the x-axis, more than one time. The points at which f of x, or the function, equals 0. So what else are these roots also called, or these zeros? I just gave it away. They could be called roots. And when you get into Algebra 2, they use that term a lot. They can be x-intercepts, or they could be called the solutions. So those are all different ways we refer to the zeros of a graph. So sometimes we can just look at a graph and we can identify the zeros, and it's pretty easy. So we look at this first graph, and here's our 0. Here's where we intersect the x-axis, and we intersect it at x equals 2. Number 2, we've got 2 places, and so we can use set notation, x equals, and we have here 0, 1, -1, -2, so x equals -2 or 1. So we look at number 3. Again, we're only looking where we intersect the x-axis. So right here, and this is +3. X equals 3. We have 0. This is the point 0, 0. We're only looking at the x value. And this is 1, 2, 3. So x equals 3. Number 4, we have 2 points where we intersect the graph. And those are x equals -1, -2, -3, -4. So x equals, use set notation, -4 and +1. So 5 and 6, try those on your own. Okay, so we're intercepting at -1 and +1, 2, 3, 4, +5. So x equals -1, +5. And here we are, this is called a cubic function, and we are crossing the x-axis at 3 places. So that would be -1, 2, 3, 4, 5. So x equals -5, here at 0, and +3. So those are the zeros of those functions. Now, we can also, if we don't have an opportunity to look at the graph, we can identify the zeros algebraically by following 2 steps. The first step is to set the function equal to 0. And then solve for x. So if we set this equal to 0, number 7, 4x minus 8 equals 0. We add 8 to both sides. 4x equals 8. We divide both sides by 4, and x equals 2. Number 8, 2x plus 2 equals 0. Subtract 2 from both sides. 2x equals -2. Divide by 2, and x equals -1. That's all you do. So try the next 4, and then come back to the video and check. Okay, so let's see how you did. We have -x plus 7 equals 0. Subtract 7 from both sides. -x equals -7. Divide by -1. Remember, we have to have x isolated. And x equals 7. Number 10. 2/3 x minus 6 equals 0. Let's add 6 to both sides. 2/3 x equals 6. Multiply both sides by 3/2, and x equals 9. Number 11, 1/2 x plus 2 equals 0. Subtract 2 from both sides. 1/2 x equals -2. Multiply both sides by the reciprocal, and x equals -4. Don't forget your negative sign there. Very common mistake. And finally, number 12, -2/5 x plus 4 equals 0. Subtract 4 from both sides. -2/5 x equals -4. Multiply both sides by the reciprocal. And in this case, don't forget, a negative times a negative is a positive, so x equals +10. And if you need to brush up on fractions, I could probably give you even some videos that would help that I've done in fractions, or just come for extra help. Okay, in this last section, they've asked us to use the graphing calculator. And unfortunately, we do not have, we can't use those this year. But what I've done is I have Desmos. I've graphed these already on Desmos. So I just want to alert you to something. We've only done this a little bit. I think you've probably done it also in 7th grade as well. In order to solve a problem like number 13, where we have a square root, and this is the only one that I'm going to go ahead and solve algebraically, but because it is something we talked about, we have x squared minus 16 equals 0. If we added 16 to both sides, we would have x squared equals 16. However, when we solve an x squared, when we isolate x when it's squared, we need to take the square root, remember, of x squared. So I'm going to write over here, the square root of x squared equals x, okay? But remember, x will then equal, in order to get this, the square root of 16, so we square rooted, let me erase this so I can write it bigger. And I'll change the color. If we've got x squared equals 16, and we take the square root of x squared and the square root of 16, we have isolated x. But remember, there are two ways to get to 16, -4 times -4, or +4 times +4. So our answer will be plus or minus the square root of 16, which would be -4 or +4. Now, I want to show that to you graphically on Desmos. So here is the graph of x squared minus 16. And if we look, we have the 0. Remember, the zeros of the function are only the x values. So we've got -4, and we have +4, which indeed is what we wrote down. So let's go ahead and just look at these on the graph. We're not going to do them algebraically. I'm just going to show them to you on the graph. We will do problems like this later in algebra, but for now, I just want you to look at the graphs. I'm going to turn off the first one, and I'm going to turn on number 14, 5x squared plus 5x minus 30, and let's find the zeros. So here we have one at -3, and we have 1 at 2. So we can go back. X equals -3 and 2. That's it, just looking for the x values of the equation. Okay, let's turn on the next one, which is number 15, x squared minus 2x plus 24. And we have 0 at let me get exactly on it, -6. And we have a 0 at 4. So x equals -6 and 4. Now we'll look at x squared plus 7x minus 8. And we have a 0 at, there it is, let me get right on it, -8. And we have a 0 at 1. Again, only looking at the x values. So x equals -8 or 1. And you could box all these answers. So now we're on number 17. X squared minus 3x minus 28. We have a 0 at -4. And we have a 0 at +7. So those are the zeros of the function, and those are the solutions. Okay, number 18. X squared. Now, I only did these dotted to just try to distinguish them one from another. The dotted line doesn't mean anything else, okay, students? So we've got, again, number 17, we've got, let's see, x squared plus 7x, number 18, I'm sorry. We've got an x at 2, and we've got an x at 5, a 0 at 2, a 0 at 5. You'll notice I always write them with the smaller value first. So number 19, again, the dotted lines mean nothing, but look at number 19. We're crossing the x-axis 3 times. So we're crossing it at -1, 2, and 4. This graph crosses 3 times, so we note that in our answer. X equals -1, 2, and 4. Number 20, x to the third plus 2x squared minus 15x crosses the x-axis at -5, 0, and 3. And the last two on this page, number 21. This is a cubic. It crosses the x-axis 3 times. It crosses at -1, 0, and 1. And the last problem on this page. X to the 4th power plus 2x to the 3rd power minus 25x squared minus 50x. This problem crosses the x-axis 4 times. It crosses at -5, -2, 0, and +5. And again, this is Desmos.com. I've shown this to you before. It's a great tool. So let's note those. That was -5, -2, 0, and 5. The last thing before our exit, I want you to start putting it all together, analyzing and describing a graph. We want to write a description of this graph, and we're going to use the elements of this vocabulary list that we are given. And be descriptive as if you're teaching someone else about the characteristics of the graph. So we're going to look at, is it discrete or continuous? What is the domain? What is the range? Is it, well, if it's a function, it's a relation, but is the relation a function? Use the vertical line test and talk about the zeros of the equation. So if we look at this equation, we see that, yes, this equation is definitely a continuous graph. It's not discrete. It's one complete line with no breaks. So it's a continuous graph. Let me get a highlighter. Okay, the domain, because this graph goes to infinity, both to the right, because eventually this will go out further and further to the right and to the left. So the domain is all real numbers. Now, does this function pass the vertical line test? And at any place where I put a line, even at that apex there, at any place where I put a line through this graph, it does pass the vertical line test. So this is a function, and the zeros of the graph are -1 and 2. So let's put all this together in our description. So the graph is continuous. Because it has connected lines. Has a connected line. Okay, the domain is all real numbers. Okay, because the graph extends all the way from left to right. The range, did we remember to talk about that? The range, this is -3. Okay, here's the lowest part. So the range is everything greater than or equal to -3. So that would be y is greater than or equal to -3, because the minimum value is -3 on the y-axis. Okay, let's talk about, is it a function? Because it passes the vertical line test. Okay, and then the zeros of the function are x equals, if you remember correctly, that was -1, +2. And that's where it intersects the x-axis. So that's it. We've analyzed and described the graph. We've found the zeros graphically and algebraically. Let's go back to our exit ticket and complete this sentence. The zeros of a function are also called the roots the x-intercepts, and or the solutions. So I hope that helped enhance everything we've been doing to kind of put it all together, especially with that analyzing the graph. Please do your homework. Try to get to it as soon as you can after you learn this, and that'll reinforce it. Many of you are turning in a lot of great work. I'm happy with a lot of what I'm seeing. You're working very hard. And all I can say is, it takes practice. And if you keep practicing and keep at it, stay positive and put your best foot forward, you'll be great. I know you can do this.